Hi students, today we can move on to module 3, interprocess communication and other communication mechanism in a distributed system. So the overview of the module includes some of the communication paradigms. They are interprocess communication. What are the ICC characteristics? What do you mean by multicast communication? What is network virtualization? And what is a group communication? It's a type of indirect communication. And also another mechanism is RPC, that's a remote procedure call. It's a remote invocation method. So these are the communication paradigms that we are undergoing in this module. So actually, this is concerned with communication aspects of middleware. We have at the top level, that is application services. Below that we have remote invocation and indirect communication. After the indirect communication, remote invocation layer, we have some interprocess communication primitives like circuits, message passing, multicast support, overlay networks, etc. And below, UDP and TCP, that is user datagram protocol and transmission control protocol. So actually, in between the application services and UDP and TCP, we have two layers. They are known as middleware layers. Okay. So interprocess communication. What is actually interprocess? Process to process communication. So in UDP, if it is a UDP protocol is following in a distributed network, and the simplest form of interprocess communication is message passing. So messages are passed between the transmitter and the receiver, or the sender and the receiver. So the sending process can transmit a single message to a receiving messages. Receiving process. Okay. Here, actually, these messages are in independent packets, though. So the independent packet contains these messages, and they are called datagram. Why? It is a UDP, or it's a protocol, user datagram protocol. So the packets containing these messages are known as datagram. It's here the sender specify the destination socket by using an indirect references to a particular path. Examples include Java, Unix API. All are used a UDP mechanism for message passing. Here the two operations are the send and receive. Sender uses the operation send and receiver uses the operation receive, and they need a synchronization between two processes. Okay, and if the interprocess communication is under TCP mechanism, here a two-way stream between the pair of processes happen. The information communicated consists of stream of data items with no message boundaries are there. So actually the stream which provides some basic building block for the producer consumer communication, like so the TCP is actually like a message passing or stream between pair of processes, like a producer consumer communication. Here the producer produces the data items and consumer consumes it. Okay. Next we have the characteristics of interprocess communication. So first we can see what you mean by synchronous and asynchronous communication. If the message passing is between the pair of processes, here already we had said that we have two operations are the send and receive. So for synchronous and so for a message passing mechanism, we have a queue is associated with each message destination. So the sending process add the messages to remote queue. Whenever the receiver is ready, it removes the message from this local queue. Okay. And the communication between the sending and receiving processes may be either a synchronous in manner or in an asynchronous manner. So if it is a synchronous in manner, here sending and receiving process synchronize at every messages that both send and receive are in a blocking operations. Why it's known as a blocking mechanism? Because whenever sent is issued, the sending process is blocked until the corresponding receiver is issued at the corresponding receive is issued at the receiver. That means whenever a receive is issued by a process, it blocks until a message arrives. So it's otherwise known as a blocking operation. But in the case of asynchronous communication, there will not be any synchronization between the sending and receiving processes. Here the send operation is non-blocking and the receive operation can be blocking or non-blocking. So if the send operation is a non-blocking means it proceeds as soon as the message is copied to a local buffer, but that means it can send messages every time the transmission of the message proceeds in parallel with the sending process. But the receiving operation can be blocking or non-blocking. That means if it's non-blocking, the receiving process proceeds with its program after using a or issuing a receive operation. So these are all about synchronous and asynchronous transmission or communication. In a multi-threaded threading environment like Java, and blocking receive has no disadvantages. Non-blocking communication seems more efficient but involves more extra complexity. So current systems generally do not provide non-blocking services. So for message passing, we have to mention the message destinations, something like an IP address plus a port number. So in the internet protocols, the messages are sent to internet address or local port pairs. They are known as actually this IP address points to a particular destination computer, and port number is an integer that specifies the message destination within a computer. So each computer has a large number of port numbers. Any process that can port the send ports know the port can send message to it. Servers generally publicize the port numbers for use by the client. A port has exactly one receiver but can have many senders. Process may use multi-port ports to receive messages. Next, we can see the location characteristic transparency. If the client uses a fixed IP to refer a service, then that service must always run on the same computer. For its address to remain valid, this can be avoided by using the following approach to providing location transparency. That is, client programs refer to services by names and uses a name server or binder to translate their names into server locations. So DNS is an example for the location transparency. For providing the location transparency in a distributed system, distributed network, this allows services to be relocated but not to be migrated to move while the system is running, but it can be relocated to somewhere else. So we have to provide the names of the client programs, and that can be translated to a server location to the IP address at runtime by using some specialized servers. They are known as DNS. They translate domain names like google.com to its corresponding IP address. And then what do you mean by reliability in IPC? A reliable communication ensures the validity and integrity. That is, a validity means a point-to-point message service is considered to be reliable if messages are guaranteed to be delivered despite a reasonable number of packets being dropped or lost. Considered unreliable if messages are not guaranteed to be delivered when even a single packet is dropped or lost. And the next mechanism is integrity. That means we have to deliver the messages in an uncorrupted form without a duplication. So that is actually reliability. It's also a characteristics of a IPC. Next, we have to be another characteristics is ordering. That means center order the delivery. Some applications require that message must be delivered in a particular order in which they were transmitted by the center. So the delivery of the messages out of center order is regarded as a failure of such applications. Next, what do you mean by socket in a message passing mechanism or in a distributed system? Both UDP and TCP uses socket abstraction. Actually, socket provides an endpoint communication between the process. So IPFC consists of transmitting a message between a socket in one process and in a socket in another process. To receive messages, a socket must be bound at local port and to its IP address. So actually the port number plus IP address is known as socket. Process may use the same socket for sending and receiving messages, but a process cannot share ports with other processes on the same computer. So any number of processes may send messages to the same port, but each socket is associated with a particular protocol, either a UDP or a TCP. So these are all about the introduction part of IPC and its characteristics. Thank you.